For a chemical reaction, we have the so-called reaction Gibbs free energy change, delta RG. Okay, for chemical reaction, the Gibbs free energy change would be the difference in the Gibbs free energy between final products and initial reactants. Between final products and the initial reactant. That will give us the delta RG, or reaction Gibbs free energy change. Remember, delta G is always final state minus initial state. And here, final state would be products and initial state would be reactants. And for practical calculation of delta RG, quite often we have something like this. Delta RG, the reaction Gibbs free energy change would be delta RG0. That means reaction Gibbs free energy under standard condition plus RT times natural log of K constant. This is what hopefully you learned from thermodynamics. R means ideal gas constant, 8.312 joule per mole per Kelvin. Okay. T would be absolute temperature and in Kelvin, because the chemical reaction may happen at ambient temperature or may happen at any other temperature. K is so-called reaction constant, and we'll go back to this later. It's like reaction quotient. That RG0 would be the standard Gibbs free energy change at standard condition. The Gibbs free energy change at standard condition typically means 1 bar of pressure, 1 bar of pressure, close to 1 atmosphere, but slightly different. And this delta RG0 is quite often calculated by this equation. Delta G, Gibbs free energy change, R for reaction, 0 for standard change, would be, okay, sigma for products minus reactant. Products minus reactant. You would have the delta FG0 for each of the product and times the stoichiometric coefficient Ni, and add them up together, the products minus the summation for all of the reactant. Gives formation energy times the stoichiometric coefficient and do the summation. Okay, so this will give us the so-called standard Gibbs free energy change, delta RG0. Take the example. Let's say we have this hypothetical simplified reaction of alpha A plus beta B to form gamma C plus delta D. So, for example, if this is our reaction, and let's assume C and D are so-called products, A and B are so-called reactants, alpha, beta, gamma, and delta are so-called stoichiometric coefficients for the chemical reaction. So for this so-called hypothetical reaction, the delta RG0, the standard Gibbs free energy change, delta for change, G for Gibbs free energy, R for reaction, 0 means it's under standard state at 1 bar of pressure. It can happen at different temperature, but at the pressure has to be standard pressure, which is 1 bar, close to 1 atmosphere. It would be the summation of delta FG0 for product C, product D, but with the stoichiometric coefficient. For C, the coefficient is gamma. For D, the coefficient is delta. You do the summation for products minus summation for reactant. A would be reactant, B would also be another reactant, and alpha would be A stoichiometric coefficient, beta would be B stoichiometric coefficient, and then you do summation for reactant. So products minus reactant. Okay, so this would be the way to calculate so-called standard Gibbs free energy change for this chemical reaction. And if you know the reaction constant, we'll talk about this in later, then you can calculate the reaction Gibbs-free energy change. Reaction Gibbs-free energy change, even if it is not under standard pressure. Okay.